Hello guys, in this algorithm, so I faced in Amazon interview question guys, this one. So here this algorithm for gifting groups at Audible, a subscriber can gift an audiobook from his or her library to any other non-subscriber to quick start their audiobook journey. The first name subscriber can receive up to maximum of N audiobooks from their friends, relatives. When a non-subscriber receives an audiobook, we can infer that the two may be related similarly. If the non-subscriber receives the gifted books from two other of them from a group, more formally, a group is composed of all of the people who know one another, whether directly or transitively. Audible would like your help finding out members of such distinct groups from input data. Consider the following matrix: 110, 110, 001. Every row corresponds to subscriber, and the value m of I and m of j determines, and if j was given a book by I. In the above example, user has gifted a book or to a user 1, and use the user connected to of 0 and of 1, while person 2 has not received a book from anyone or gifted a book to anyone. Therefore they're in a matrix of two groups. So m of I, m of j equal to 1. If I equal to j, each of the people is known to self. Determine the number of groups represented in a matrix. The method signatures may vary slightly depending on the requirements of the chosen language. For example, C language will have an argument that represents the number of rows or number of columns in the matrix ALOS. Java will receive the list of rather than an array. CountGroups has following parameters related n and an array of strings of binary digits related of I. The represent connections of people. So I'm going to explain this one in Java under JavaScript, guys. I'm not going to do it in under the either C or Java, but then I want to do it in JavaScript, say plain JavaScript, vanilla JavaScript. So let's go and have a look. And after finishing this algorithm, guys, I would like to explain about the big notation, time and space complexity of this one as well. Let's go and have a look in my Visual Studio Code, guys, and where it is. So here I already did one. Let me remove it. And already I created the folder, guys. In this folder, index.js, in here, what I'm going to do, first step, here I would like to take a constant matrix. Okay, here, okay, constant matrix. In this matrix, as he mentioned, I would like to take in three things: 110, comma 110, comma 001. Okay, and then this matrix, just I would like to take in output in count groups. Okay, in these count groups I would like to pass in this matrix. Okay, sorry, matrix, just I would like to pass this matrix. So now, as we mentioned, first step 1, so count groups, just in first I want to do it in step by step over here. Here I would like to declare the function. Okay, count groups is equal, okay, the function. In this function I would like to take a matrix, right? So I would like to pass in this matrix over here. In this matrix, just I would like to do constant n equal to matrix dot length. Okay, matrix dot length and a constant visited equal to new array of n. You know, right, guys, this one is filled with what it is going to be happen here. It will go to false, like in how many arrays is there, the length, based on the length it will go to fill with the false, that one. So once I have done this visited to either true or false, and let groups, I would like to take then a groups equal to 0. So see here what I'm going to do, let I equal to 0. Okay, I less than of n is the matrix length. Okay, and then here I would like to increment that value, and then if is not there, the value is not there in the visited. Okay, the visited of I. each I is not there in the visited, in the false, either true or false is coming, right? Visited means is going to give the false, like the each and every value of the false. If it's not there, then I'm going to create another method, that is another function. That function is I'm going to pass is matrix over here, and matrix and visited. Okay, visited means is all the array values, fill values, and as well as an I is going to give an n. Okay, and here I'm getting an n, and then here if it is okay, and then I will go to increment these groups. Now I would like to take this DFS, okay, this DFS, and go up, and here what I'm going to do, function, in this function DFS, in this DFS we have the matrix, comma visited comma user. User means an I, and n is the length of the matrix. Okay, so I'm getting in all these values, and then here I'm going to do visited of user. What I'm going to do here, I'm going to check that one if it is true, or whether true or not. Okay, I'm going to make this one true initially. So once I will make the true, let I equal to 0, let I equal to 0, I less than of n, and I plus plus. Okay, once I'm getting this value, if matrix, okay, if matrix of user of I, okay, matrix user of I is equal to, here what I'm going to do is equal to 1, if, and here what I'm going to do, so not visited, okay, visited of I, okay, not visited of I, then oh sorry guys, here I did a mistake over here, user of I, and then here it is not required, this one is equal to 0, and then here, and then here what I'm going to do, I'm going to do in recursive, and this recursive just I'm calling again matrix, and just visited, and then I comma n. Okay, all the values I passed it, and then we'll go and see guys, and what is the output, and should be, the output should be in 2. Okay, output should be 2. So based on the matrix, whatever values you are giving, and this gifting card. Okay, let me copy this relative path and go to F11, and then I will go to do in terminal. So I will put it down, and then I will go to do it over here, and let me clear this thing. Okay, clear it, and then I would like to undefined. Why it is undefined, guys? Let me have a look again. Output should be in 2 guys here. Function, what I did mistake over here. Let me have a look. Is equal to true visitor, let I equal to 0, I less than n, I plus plus, and the matrix of user of I is equal to 1, and not equal to visited of I is correct, and the DFS matrix visited I comma n, yeah, that's correct. Oh okay, here I did not return guys, that's the reason is throwing an error, so sorry. Return groups. Okay, I need to return that groups, then only you can able to see what is the count groups. Okay, so let's go and have a go for again guys. And so here I want to do it again. See guys, the output should be 2. The count groups are coming as expected guys. So now just in depth first search, if you know depth first search guys, and you can able to tell in easily, you know, is commonly DFS is used for various applications guys, that one such as finding connected components, graph, detecting cycles, solving puzzles like mazes, generating topological ordering, all these things are coming, guys. And if you know very well in the DFS and depth in first search, and then this algorithm is very easy to do it, guys. Then that is one of the data structure, you know, that you need to learn about that one. So before jumping onto this to learn, let's go and have a look in big one version, guys, for this algorithm. I would like to explain about that. So here, so the big O time and space complexity of the given DFS algorithms, guys, can be analyzed of as possible as follows. Like in time complexity, the time complexity of DFS algorithm depends on the number of vertex users in this case edge connection between users. In graph represented the adjacency matrix, visiting each vertex once, OV, and where V is the number of vertex, checking the each edge once, and that one is going to OE, where E is the number of edge cases. So since we are using adjacency matrix, the time complexity of the checking on edge matrix user of I is O1. So therefore, the overall time complexity of this DFS algorithm is O of E plus V. So now space complexity, the memory, how much memory is occupied this particular algorithm depends on the size of the adjacency matrix, the size of the visited array, of the recursion depth, guys. And as I mentioned earlier, like we are using in recursion depth. So adjacency matrix and V 2, and where V is the number of vertex and OV is the stores of Boolean value of for each vertex, an array of fill. I did fill, right, guys, in the program. So that one. Recursion depth is I used the recursion depth in after that, and then that OE is the worst case connected to graph with vertexes, and therefore overall space complexity of this particular algorithm is O quadratic, right, and V quadratic 2, and due to the adjacent matrix dominating space usage. The time complexity is linear algorithmic V plus V, guys. This one is the space complexity is little bit is quadratic, guys, and worst scenario, worst case, guys. So that is the algorithm, that is the time and space complexity, guys. That's all in this video. I hope you are enjoying this video. Please subscribe my channel, guys. I would like to make in more algorithms for your sake. Bye bye, guys, for now.